All right, welcome back. You've absolutely crushed the basics: entities, attributes, relationships, all that good stuff. So now we get to the part that really separates a class project from a rock solid professional database. Today, we're going to build the guardrails and the blueprint that make our data practically bulletproof. Let's dive in. So, I want you to just think about this for a second. It sounds completely insane, right? Your best customer calls to update their phone number. Simple, should take 5 seconds. But what if making that one tiny change could silently, secretly break your data, creating conflicting records across years of their purchase history? It sounds like a crazy bug, but it's actually way, way more fundamental than that. And here's the kicker. You can't just patch this with a few lines of code, because it's not a bug. It is a flaw in the very blueprint of the database. It's called an update anomaly. And it's basically a symptom of a really messy, disorganized system where you've got the same information just copied and pasted all over the place. And believe me, this is just one of the gremlins hiding in a badly designed database. So, this all starts with what I call the junk drawer problem. You know that drawer in your kitchen with the rubber bands, the half-dead batteries, the takeout menus? We all have one. And we're all tempted to build our first database the same way, just shove everything into one giant table because it seems easier. But that's where the classic garbage in, garbage out problem begins. Okay, so here it is, our junk drawer in all its glory. Now, once you see the problems here, you won't be able to unsee them. First, look at this. Item 1, price 1. Item 2, price 2. I mean, what if someone buys 10 things? Are we just going to add columns forever? That's just nuts. And even worse, look at Jane Doe's info. Her name, her phone number, copy-pasted for every single item she buys. That right there is a ticking time bomb.
All of that repetition, it creates three specific kinds of nightmares. They're called anomalies. We already talked about the update anomaly with Jane's phone. But then there's an insert anomaly. Let's say we hire a new salesperson, Lisa. Well, where do we put her info? She hasn't made a sale yet, so there's no receipt to add her to. We literally can't add her to the database. And then there's the scariest one, the delete anomaly. Tom returns his items, so we delete those receipt lines to process the refund. And if that was the only place Lisa's info was stored, poof, she just vanished from our entire system. Gone.
So how do we stop this chaos? We don't just cross our fingers and hope our application code catches everything. No way. We build the rules, the guardrails, right into the database itself. And these powerful rules are called constraints. I love this analogy. Think of constraints as the bouncers at an exclusive club. They stand at the door to your tables, and they check every single piece of data that tries to get in. If the data doesn't follow the rules you've set, it gets rejected. Nope, you're not on the list. This is what makes your database smart. It stops being a dumb container and starts actively protecting itself from garbage data, 24/7. Now, two of your most important bouncers are the primary key and the unique constraint. And people get these mixed up all the time, but it's simple. Every table gets one and only one primary key. It's the official, non-negotiable, government-issued ID for that row. It can never, ever be empty. But then you can have lots of unique constraints. Those are for other columns where you can't have duplicates, like an email address or a social security number. So really, these three are the bedrock of any solid design. You've got your primary key, giving every single row a unique identity. You've got the foreign key, which is the magic connector that links tables together. And you've got good old not null, which is the simplest bouncer of all. It just says, hey, this field is required. You can't leave it blank. Together, they form a web of trust. Okay, so we have our rules. Now for the really cool part. How do we clean up that junk drawer table? This step-by-step process is called normalization. And honestly, the best way to think about it is like finally organizing a messy closet. You have to dump everything out onto the floor, sort it into logical piles, shirts, pants, shoes, and then put everything back where it actually belongs. Our first step on this journey is called first normal form, or 1NF. The rules here are simple and absolutely non-negotiable. 1. Every single cell holds one and only one value. No stuffing comma-separated lists in there. 2. You have to get rid of those repeating groups of columns, like our whole item 1, item 2, item 3 disaster. And this is what our table looks like after we apply that rule. See? We fix the repeating columns by giving each item its very own row. Now, I know what you're thinking. You're looking at this and going, wait a minute. This looks worse. Now Jane's info is repeated even more. And you are 100% right. It looks messier. But trust the process. This is a totally normal and necessary step. We're just making a bigger mess before we clean it up properly.
All right, on to second normal form, or 2NF. This rule sounds kind of academic, but the idea is to fix the mess we just saw. In our last table, the primary key, the thing that makes a row unique, is the receipt number and the item name combined. You need both. But ask yourself, does the cust name depend on both of those things? No. Jane's name only depends on the receipt number, not the specific item she bought. That's a partial dependency, and 2NF is all about stamping those out.
So how do we fix it? Well, we do the intuitive thing. We break the table apart into logical groups. We make a table just for receipts. We make another table just for items. And this is the magic part, we make a third special linking table called receipt_items that just connects the other two. Now, every piece of data is living in a home that's actually about it.
And boom, just like that, we get a huge win. Check out our new items table. The price for a laptop now exists in exactly one place in the entire database, one spot. So if we have a price change, we update it once and it's instantly correct everywhere. One of our original anomalies, fixed, gone.
Okay, time for the final cleanup step. Third normal form, 3NF. This one targets something with a fancy name, a transitive dependency. It sounds complicated, but the idea is actually super simple. It's just a piece of data that's secretly a fact about another piece of data in the table instead of being a fact about the table's actual key. Just look at our receipts table here. The key is the receipt note. Now, let's look at the cust phone column. Is a customer's phone number a fact about this receipt? No, it's a fact about the customer. It depends on the cust name, which isn't the key. Same exact thing for the seller's phone. It's a fact about the seller. These are transitive dependencies, hiding in plain sight.
And this brings us to the ultimate mantra for database design. It's a little pledge, a tribute to the genius who invented all this, Edgar Codd. To have a clean 3NF table, every single column must describe the key, the whole key, and nothing but the key. If you can burn that into your brain, you will always be on the right path.
So, by following that one simple rule, we complete our organization journey. We take those last few misplaced facts, like the customer's phone number, and we give them their own proper homes. What we're left with is no longer a messy closet, but a clean, elegant, professional blueprint for our data.
And would you look at that? It's beautiful. Customers now have their own dedicated table, with a customer ID as the primary key. Salespeople have their own table. Jane Doe's phone number now exists in one single cell. All of that dangerous, messy repetition is finally gone for good.
And now, look at what happened to our receipts table. It's so lean and efficient. Instead of copy-pasting customer names and phone numbers over and over, each just stores a customer ID and a seller ID. Those numbers are foreign keys. They're just pointers that link back to the single source of truth in those other tables. This right here, this linking with keys, this is the beating heart of relational databases. And with that, we've done it. Every single individual fact about our business, a customer's name, an item's price, a salesperson's phone number, now lives in one and only one place. The update, insert, and delete anomalies that we were so worried about, they are now structurally impossible. They literally cannot happen. Our database is clean, reliable, and professional.
So let's just recap the superpowers you've unlocked today. You now know how to use constraints to act as bouncers and prevent bad data from ever getting in. You have a step-by-step process, normalization, to systematically hunt down and destroy data redundancy. You have the skills to design schemas that aren't just for a small project, but that are scalable and professional.
You know, this isn't just theory from a textbook. This process, these ideas, this is the solid foundation that nearly every major application you use is built on. You now understand the blueprint. You have the tools to build a database you can trust from the ground up. So really, the only question left is, what will you build with it?